Hello, participants. Believing that we are now familiar with descriptive statistics, we now proceed to estimation of technical, allocative, and overall efficiencies. To do this, let us not forget to set our directory. So I'm still using DA trainings. So I open it and we are still using FDAT data set. So we click on file so that let's import the data sets afresh. We are doing this just to remind us the routine. So import data set. So retrieving the data, that's fine. So we import the data set. So in terms of packages required, we will need DAR. We still need tidyverse in order to manipulate our data sets. And a situation whereby we need to export our data to Excel, we shall still make use of write Excel. By way of reminder, so let's check for the names of the columns. So this is just to remind us. If you look at the columns, we have size type, city, and industry. I think ownership too. So some of these variables are actually in string forms, they are characters. And we don't need them because in estimation of our efficiencies, we just need direct production inputs. So we need to select variables that we need. We don't need all these 15 variables, so we just need a few of them. So to do that, and that is the reason why we are manipulating our data using tidyverse package. So let us call the new data set fdat1. So equals to fdat percent greater percent select. So we have to select the variables that we need. We need the firm because that is our decision making units. We have labor, materials, capital sales, then the prices of the inputs. Those are just the information we need to estimate the three types of efficiencies. One other thing we can quickly do is to export this fdat1 to Excel. To do that, we use write XLS as fdat1 and we call it fdat.xls. We run this, is going to, okay, let's run the two now. Yeah, it's not running it because of permission, unless we change the name, because it's already in the working directory. So let us not worry ourselves. Now Before you can use f.1 to estimate, you need to read the data set. So to do that, we use the function read under data. This function is in DAR. So, and we want to generate data sets that will help us to compute the technical efficiencies. So we have TA that read underscore data. So we have f.1, that is what we want to read. And if you look at, let us look at the names again so that you look at the position of, we now need f.1. So let me get names f.1. So now if you look at it, you have inputs. Our inputs start from labor. So we have labor material capitals. This is column 2, column 3, and column 4. So we have the inputs from column 2 to column 4. This is what this is showing us. Outputs, we just have one output, which is sales, and so you can find out in column 5. That's 1, 2, 3, 4, 5. So, and in order to estimate the technical efficiency, you just need the input and the outputs. Their prices are not required. So the moment you have read the data, the next thing to do is to define your model. So let's call it T model. So the function is model underscore basic. So this is the data set that we have read, that is T that. Then you define your orientation. Your orientation is either input output or output input. Then you define your return to scale. So we say we are using constant return to scale. So if properly defined, then you can run your model. So we have our model, and after that you can now obtain your technical efficiencies. And we want the technical efficiency to be included in f that. That is why we have f.$te. So we are naming te to be included in f data sets. And the moment we have done that, the function to calculate the efficiencies is efficiencies. So it's very, very straightforward. Efficiencies, then the model. So let's run this. Yeah. So the T here is already in f that. You can just look at your f that here. So you can, if you go towards the end, this is the TE already estimated. But in case you want to show it on the RStudio console, if that is what you want, then you can just have here f that dollar TE. So TE, yeah, just run it. So it's going to show you, you can see. So up to 825th firm. The next thing is, after estimating your technical efficiency, then you need to estimate the cost efficiency, or sometimes called the overall efficiency. For the cost efficiency, again, not to forget the names of the variables. In this case, the only difference is that now we want to account for the prices of different inputs. So I want you to please take note of what we are trying to do here. You define the input price. So the input price In the way to define it, you have to take the transpose. So that transpose is f dot 1. So if you look at f dot 1, that is column 6, 7, 8. So it's in column 6, 7, 8. So that is why we have these square brackets. This square bracket, comma, this is indicating that we want to consider column 6, 7, 8 as the input price. So we get the transpose. So the moment you have the transpose of the price, then you have to define you have to read your data. So to read the data is pretty straightforward too. So what is needed again is read underscore data. We are now reading f dot 1. The number of inputs, we have 3, that's labor, materials, and capital. The number of output, that is NO, is 1, which is sales. So the moment you have defined it, so let's run the input price as well as the overall efficiency data. So run. Okay. So after running it, then you have to define your model. So here we have the OE model, and instead of model basic, here you use model profits. So if you are interested in profit efficiency, cost efficiency, revenue efficiency, then you use model underscore profit. Because you are accounting for the prices of the inputs and the outputs. In case of profit efficiency, you are accounting for the two prices. In case of revenue, you are accounting for the price of the outputs. But in case of cost efficiency, you are actually accounting for the price of the input. That I think is very, very clear from theoretical point of view. So you have model underscore profit. So you have the data set, which is the one that we have read, and you now define the price of the input. That is the one we define as the transpose here, that is this. Then you define your return to scale. So we're using constant return to scale also. So if you have done it, then let's run it and see. So run. That's fine. So the moment you have run it again, you can obtain your efficiencies. Let's say you want the efficiencies. You want to view the efficiencies on the out console. You just run this way. So it's going to show the result up to 825. So now that you have the cost efficiency and you have the technical efficiency, to obtain your allocative efficiency is just the cost efficiency divided by the technical efficiency. So that's clear. Or multiplication of the technical and allocative will actually yield the cost efficiency. So what you now need to do, since you already have your OE, you have your TE, then you calculate your AE, but I want that AE also to be included in FDAT. So I have my FDAT $AE, that's what I've called it, equals the OE divided by the TE. So, and but don't forget, we run this so that we have it on the console, but you have to give it a name. You want your OE to be in the FDAT, so we have FDAT $OE as the efficiencies here, so that it's going to be on the table. Then again, your AE will be on the table. That's all right. Yeah. So, and now we have FDAT. If you click on this FDAT, we have all those efficiencies cost there. So let's look at it. This is the FDAT with all those efficiency stuff. So this is TE, OE, and AE, for instance. So it is included in the table because yeah, you may want to look at sources of the inefficiencies using some variables that you already have, and in that wise, definitely, it's going to make it easy for you to run the second stage, either using 2-bit or you use linear regression. So let's look at few other things that we need to do. Yeah, you can actually, for instance, you may need to obtain the technical efficiency, allocative, and economy by certain variable. Let's say we want to group those efficiencies by city, for instance. So we really want to know which city has the highest technical efficiency, or we want to look at which city is most economically efficient and sort of things, so that we can make some comparison and investigate why and so on. So if that is what we want to do, that is again unit ID verse. So let's call it CTF, that is city efficiency. That's F that, then group by city, then summarize each. This function, let's use mean. So you have the mean for TEAEOE for the city. So after that, then we write it to Excel. So if you have done it, let's run it and look at our results. Yeah, it's fine. Yeah, no, permission is denied. Don't worry about that because we already have it there. So unless we change the name, it won't allow us. So let's get to city. Let's check it. That city. The training, that is CTF. Oh, sorry. Let's check the name. Okay, CTF.XLS. Yeah, CT. Okay. So let's look for it. Yeah, CTF. That should be up there. Okay, this is it, CTF. So let's check it. Yeah, so here we are. So now you have the city, you have the technical efficiency, the allocative, and the cost efficiency, or the overall efficiency. So let's arrange this in let's sort it in descending order. That's from largest to smallest. Expand the selections. So in that wise, you see that Damatru happens to be the most technically efficient. Yeah. And let's look at the cost efficiency and let's sort largest. Let's expand the selection. So you see that in terms of the overall efficiency, then you see that Ibadan happens to be better than others. Yeah, so you can now compare, contrast, and so on and so forth. So, and you can proceed from here to look at what are the drivers of either TEA or OE. Yeah. So that is how to do the estimation. We'll proceed from here to look at total factor productivity. Specifically, we are going to look at estimation of Marquis index. And after the estimation, we see how to proceed to the second stage. So maybe using panel regression or some other methods such as GMM, or what have you. So thank you very much. So this is uh, what what we have just covered thus far. Till tomorrow, or I remain yours,